The overall goal of this procedure is to assess a patient's balance objectively with the use of computerized dynamic posturography through 2 diagnostic tests. This is accomplished by first ensuring the dual force plate support surface and visual surround are calibrated. The second step is to position the patient's feet correctly on the support surface and to secure the patient by attaching the safety harness to the safety bar. Next, the sensory organization test and the motor control test are performed. The software automatically computes the patient's score and variables of interest relative to an age-matched normative dataset. The final step is to assist the patient down from the platform and discuss their results. Ultimately, computerized dynamic posturography is used to identify possible deficits in the somatosensory, visual, or vestibular systems, and can also determine if a patient has a visual preference by relying on visual information even when it is inaccurate.
The main advantage of this technique over existing methods is that computerized dynamic posturography can measure balance objectively, and it can quantify postural strategies in both static and dynamic conditions. It is intended to complement existing clinical outcome measures that categorize mechanisms of balance disorders. Visual demonstration of this method is critical because it is important for the investigator to understand the sequence of events. These include stable versus unstable support surfaces, static versus dynamic conditions, eyes open versus eyes closed, and conditions that are graded in magnitude. A PhD student from my laboratory, Amartya Ganguly,